A patient is taken into the emergency room because his heart has stopped beating. The emergency room staff immediately give him CPR. However, it is ineffective because the fluid surrounding his heart is squeezing it and preventing it from refilling at all. Now let's take a closer look at the patient's heart. There is a membrane called the pericardial sac that surrounds the muscular heart. The space between the sac and the heart, called the pericardial space, is filled with some fluid that lubricates the heart as it beats. Excess fluids, known as effusions, can accumulate due to several diseases. Severe effusions, known as cardiac tamponades, occur when fluid pressure prevents the heart from pumping or refilling altogether. Physicians can perform a procedure known as a pericardiocentesis in order to drain this excess fluid by inserting a 6-inch needle into the patient's chest and into the pericardial space. However, the needle unintentionally punctures the heart in up to 50% of these procedures. 1 in 4 people will die due to heart punctures. We, Team 5 of Hearts, saw the substantial need to confront this issue head-on.
As cardiovascular-related problems grow in prevalence, we have an ideal market where we can create value and save lives. 32,000 pericardiocentesis procedures are performed worldwide annually, making our global market approximately $160 million. As the U.S. comprises about 40% of this market, our main source of profit is valued at $64 million. While our primary focus is pericardiocentesis, our market can be expanded when considering other procedures that require pericardial entry, such as epicardial ablations. After consulting cardiologists, we developed a device that allows physicians to enter the pericardium safely to drain excess fluid. Introducing the SafeCentesis, a pericardial entry tool that has 3 key features. First, a rotating advancement module that limits entry into the pericardium to a safe distance of 1 centimeter or less. Second, a novel half-coiled needle tip that works hand-in-hand with the mechanical advancement module to insert the needle parallel to the heart. And third, a real-time algorithm that identifies where our needle tip is located using ECG data, in which ST elevations indicate contact with the heart and baseline drift signals pericardial entry.
We were able to verify the functionality of our SafeCentesis device using both cadaver and sheep heart testing. We simulated a real pericardiocentesis procedure and determined the distance that the standard 18-gauge needle and our device advanced past the pericardial sac. Our testing showed our device performed well within range of our target metric. Our device advanced only 7.5 millimeters past the pericardial sac, which was over 3 times less than that of the conventional 18-gauge needle. Furthermore, to confirm the efficacy of our real-time algorithm, we use publicly available ECG datasets in order to determine our capacity for feature detection. We found that we can determine heart contact with a specificity of 86% and a sensitivity of 75%.
With SafeCentesis, we hope to help save weeks of prolonged, painful hospital stays and reduce costs by over $50,000 per patient. We wish to reduce the mortality of the procedure and help save thousands of lives. And not only are we creating a safer environment for patients, our novel approach to minimize risk of cardiac perforations will also increase physician confidence and enable further, more advanced treatment into the pericardial space. Moving forward, we're confident to optimize the SafeCentesis and bring to market. To make the SafeCentesis a widely distributed project, we aim to refine our mass manufacturing process of our half-coiled unit. We're also working to optimize our real-time analysis of existing ECG machines. Further, we plan to incorporate automatic retraction when hard contact is detected. With these, we'll apply for FDA approval prior to manufacturing.
SafeCentesis would be classified as a Class 2 device, which means that we would need to file a 510(k) to demonstrate that our device is substantially equivalent to another already cleared by the FDA, such as a hypodermic needle. Additional clinical studies will also be conducted to further ensure the safety of our device. With the help of SafeCentesis, we are confident we can prevent broken hearts during pericardiocentesis and save millions of dollars in excess costs. We are ready and eager to move forward with our project, so make the safe bet with Team 5 of Hearts and invest in SafeCentesis.